Hello, this is Alex Eames from RasPiO.tv.
Hello, today I'm going to show you how to assemble your RasPiO nightlight board. Here's the bare board, and when it's built it should look like this. And when the case is around it, it should look like this. First, let's have a look at the kit contents and then we'll start building it. Here's the kit contents. We've got a bag with 4 acrylic parts in, a top, a bottom and 2 sides. Here's a passive infrared motion sensor. Here's the RasPiO Nightlight PCB. Here's your Arduino Nano clone. Here's a mini USB to USB cable. And here's a bag with all of the remaining components, the necessary nylon hardware to complete the case. In the little bag you should have a piezo buzzer, a light sensor, an LED, 4 nylon nuts, 4 nylon spacers, 8 nylon bolts, a 3-way female header, 1 330 ohm resistor and 2 10k resistors. When you open up the Arduino Nano bag, you'll see that there are 2 headers, one for each side and 1 ICSP header, which we won't need. You can solder it on if you want, but it won't be necessary unless you want to use that to program it instead of the mini USB. Generally, it's easier when you're assembling a board if you do the lower components first and build up gradually with height. So we'll start with the resistors. For my own personal builds, I always use 0.7mm leaded solder. You can't use it for products for sale, but for your own personal builds it's absolutely fine, and I like it because it flows really well. So here's all the components that we're going to solder laid out on the board near where they're going. We've got the buzzer, which goes here, the light sensor, which goes here, doesn't matter which way around that goes. The buzzer is plus and minus, and the long leg is plus. We've got the female header which goes here. It needs to be nice and upright so that it gives the peer sensor the right positioning. Here's the LED, which is an indicator for the peer sensor, and that goes negative side that way around. You'll align it correctly with the markings on the board and it will be fine. Here we've got the 330 ohm resistor and 2 10Ks, R1 and R2. These are the 10Ks, that's the 330. And we've got the Arduino Nano clone. You can solder these headers either long side down or long side up, and it doesn't really matter, except to say that if you want to put them long side down so it's a bit neater on top, you'll need to trim them from the underside of the board. Okay, now let's start building, shall we? Okay, so we've got 3 resistors to fit, R1, R2 and R3. R3 is the 330, which is the single one. It has colour coding orange, orange, brown, gold. Gold means it's a 5% resistor, 5% tolerance. So let's be fussy and put the golds all pointing that way because we're doing it on film. So that's the 330, goes in position R3. Alright, I'm going to bend those legs like that. And let's fit them all while we're at it. So now I've got the 2 10Ks and I want them gold that way. Let's just bend the legs so they fit and slide through and then bend on the other side. Okay, that's better. Gold facing that way. Third one, making sure it's in the right hole. Good, that one's fine. Now we can turn it upside down and solder each of the 6 holes. I'm using a Hakko soldering iron at 350 centigrade. Usually I would use an extraction fan to get rid of the fumes, but because that makes a horrible noise and you don't want to have to listen to that, so I've not got it switched on right now.
Okay, that's 2. So you place the soldering iron touching both the pad and the wire and dab some solder, leave it for a few seconds, touch, dab and take away, touch, dab and take away. You might find the earth ends, the grounded ends, could be a bit more difficult to solder just because they're connected to the ground plane, so you're heating up a bigger amount of copper. Right, let's have a good look at those. I wasn't sure if I did the first one very well, but that looks okay. Then you'll need to snip the excess of the leads away that you don't want anymore. Okay, there's just one more to do. Got you. Alright, resistors are done. Let's get rid of the scrap. Next we'll do the buzzer. So the buzzer has several ways of telling you what the polarity is. It's important that you get it the right way around. Plus goes to here, minus goes to here. So this one is plus, and the other way of knowing, once you've taken the sticker off, which is plus and which is minus, plus is the longer leg, which is the same as with LEDs. There's no reason why you shouldn't leave the sticker on until later, so that you've always got an indication of which way round it is. Sometimes the legs of these things can be a little bit murky, so sometimes if you need to, give it a bit of a scrape. This one looks okay, but sometimes they can be a little bit murky. So this positive side, longer leg. You want to push the longer leg through so you're sure you've got that right, and the shorter leg goes through negative. Great. So let's turn that upside down. If you want to, you can use a sponge here just to hold things in place. It's not strictly necessary for this board, but I have been known to use that on certain boards in the past. Okay, so this longer leg will do first because it's likely to be slightly easier, and that will hold the board in place. Okay, that's done. Now the shorter one, which goes to ground, may be a little bit more effort required here because it's connected to the ground plane. Bit more heat. That looks fine. Closer inspection. That looks great. Now let's snip the excess of the leads away, leaving us with two joints. Okay, we now have a buzzer. Next stop, LED. You'll notice on the LED one side has a flat. One side has a flat. That's also the side with the shorter leg. Both of those are ways of telling you that that side is negative. The longer leg is positive, and the longer leg we want to go on this side. So when the LED goes down onto the board, you should see it fits inside its footprint. If we put it the wrong way round, it doesn't fit properly. Yeah, because the flat's on that side now, and it shouldn't be like that. Flat should go to its correct side. Okay, so we're ready to turn that upside down and solder it now. We'll do the longer leg first, positive, because it'll be the easier one of the two. And wasn't that easy. This is the negative. And you can see it's just finding it a little bit harder. Okay, that's fine, that's joined. I'm happy with that. Let's just check that it's properly perpendicular. Yes, it is. In that case, let's snip the excess of the leads away and chuck them in the bin. Alright, so what's up next? Light sensor. Now the light sensor, the legs on these are actually pretty flimsy, so I've found the best way to do these is actually to push them in quite far, much further than you might think. Probably about that far, so there's about less than a centimetre, maybe 6 or 7 millimeters sticking up between the PCB and the light sensor. Then the fact that the legs are a bit flimsy doesn't cause any problems. So we'll bend one of the legs out and then solder. The light sensor can go either way around, it doesn't matter because it's not polarized. It's just a resistor basically whose value varies with the intensity of light that it's exposed to. Okay, so let's check we've got that reasonably okay, and there is flexibility. You can push it around a little bit after it's soldered, but don't push it too hard because you don't want it to break. Okay, we're motoring. What's next? The header. This three-way female header goes here, doesn't matter which way round, but what does matter is that it's pointing nicely perpendicular, because this is what gives your infrared motion sensor its alignment. So it needs to align with the hole in the case, and if you had it like that, it wouldn't work very well. It needs to be nicely perpendicular. So I am going to use a sponge for this one. So I'll plop the sponge on top, and that will hold everything in place while I solder. So what I'm going to do is I'm going to do one pin first, not the ground one, which is that one. Then after doing one pin, I'm going to check that I've got it lined up properly. That looks great for once. I've done it correctly first time, on camera as well. Okay, so now we solder up the rest. I blow the smoke out of the way because obviously my fan is not active and I don't really want to breathe in those flux fumes. Okay, so that's the header all sorted. Actually, at this point I'm going to interrupt this transmission to open the passive infrared sensor, check that everything's lined up properly, and push that on there. I'm going to take it off again, but I just want to check that I've got this right. Good, that looks fine, that will fit. So I'm going to take that off again now, and we'll carry on with the build. So the last component we have to fit is the Arduino Nano clone. So later on you're going to put two spacers there, and the Arduino Nano clone goes between them, and it's a little bit of a tight fit. So what we can do to help at this particular moment is take a bit of sandpaper and rub the ends. Just move the board out of the way so it doesn't get dusty. Take a bit of sandpaper and rub the end of the Arduino Nano clone a little bit, just to make sure it's smooth and there's no extra material in the way. And if you need to, you can do a little bit at this end, either with a knife or with a bit of sandpaper, just to be sure that everything will fit nicely. And actually you can see the sides of the board are a little bit ragged as well, so I'm going to be Mr. Fussy and tidy those up as well. As I said before, you can do this either the best way for you to see. You can do it either long side upwards or long side down, and it's the outer holes you need. The reason why the inner holes are there is so that if you want to use any of the ports on the Arduino Nano clone, you can hook up your own components to any of the ports which aren't used. So let's do it the easy way. So I'm going to get my trusty sponge out and use it just to raise the board a little bit so that it's not sitting on the surface. Okay, I'm going to do the four corners, tack them in place, and the reason I'm doing it like this is to try and make sure we have good alignment. Also notice I was pushing the board that way slightly because I found in assembling these that sometimes you're more likely to get tightness on this side than you are on that side. So just pushing it slightly does not make a huge difference. But you might as well use tolerances to make life as easy for yourself as you can. So let's just do this end. And this end. Can you see that still? Yes, good. Okay. So now I'm fairly confident that these are going to be lined up well enough that it can fit in the board. So I'm going to take that off, get rid of the sponge, and just buzz round the Nano. I'm going to start from the middle and work outwards, alternating. The reason for doing this is to try not to allow too much heat to build up in any one place on the board. Should sing a song or something to entertain you, just to guarantee that you'd unsubscribe. Right, this is a ground pin, so it might take a little bit more heat. Okay, flip that round. Let's do the other side. These are the analog ports I'm doing now. Oh dear, I just moved one of the pins. I hope that didn't mess it up. If you're worried about that happening, you can leave it in the PCB. The reason I pulled it out of the PCB was just to try and avoid any possibility of damaging PCB's LEDs. Electronic components don't like heat, so if you can minimize the amount of heat they get exposed to, you reduce the risk of damage. Okay. Alright, so that's the pins soldered to the Nano clone. Let's have a closer look at those. Because the pins are tall, the solder has wicked part of the way up, and it makes me look like an amateur, which is fine. I don't care. I'm not looking to win any presentation awards here. What I do want though is for this to be able to fit nicely in the PCB, and it does. It's a little bit tight. I think perhaps I pushed a couple of the pins slightly out of alignment, but not enough. Not enough to make it matter. Right, let's use the sponge so that when we press down on the board it applies a bit of pressure and keeps things tight. You don't want the nano falling out. Right, let's put that joint and that joint. Okay, now we've just got to buzz around the rest of the board. Let's check before we commit completely. That's pretty good, that'll do. Don't need the sponge anymore. Now we just buzz around the board. Soldering up the pins. Okay. As the guy on the Will It Blend videos says, don't breathe this. It's not lead that's harmful here, it's the flux vapor, and it actually isn't harmful to everybody. Some people, I'm afraid I'm one of them, finds that it sensitizes the throat. So if I breathe this stuff, tomorrow I'll be croaky, and it's very uncomfortable as well. You're already croaky, I hear you say. Shut up. Who asked you? Right, this is a ground pin, so it might be a little bit more heat required to get the job done. Go away, smoke. So now onto the analog pins. We use one of these for reading the light sensor, because that's an analog device. But the rest of the analog pins are free and available for use. I think we use D5 and D7 to drive the LEDs on the, the main SK9822 LEDs. The RGB ones, and pin 13 drives this LED, and another two pins, I've forgotten which ones they are actually off the top of my head. One reads the lights, one reads the motion sensor, and another one fires the buzzer if you want to. It's all programmable. Excellent, so we now have all of those connected. Fantastic. The last thing to do is to fit the motion sensor and whenever you want to, you can remove the sticker here. I tend to leave them on because it makes the sound a little bit less piercing. So you've assembled your board. Now we want to take the case parts and put them around the board so that it ends up looking like this one. So the case parts look like this. This is the bottom, this is the top, and the motion sensor pokes through there. This is the right hand side where there's a hole for the micro USB cable to fit through, and this is the left hand side. That would be assuming you put it with the infrared sensor at the top. And there's a bag with your hardware in. The first job to do is to peel the protective film off all the case parts, because Perspex is lovely shiny material, but it does tend to scratch if roughly treated. So it ships with protective film. It shows more on glossy when the surface gets damaged slightly. These are frosted because it diffuses the LED light very nicely, and this job is made harder because I cut my nails for the video. People used to harangue me for my nails when I was first getting started in YouTube, so now I try to make sure that they don't look too long and girly so nobody gets offended. Right, first thing to do is get those bits out of the way. We're going to focus on the base first. Right, so you'll need a small crosshead screwdriver. I think this one will fit. Yes, it does. Fantastic. So you need something like that. And the idea is we're going to put one bolt through each hole and do the screw up, tighten it so that it's not quite fully tightened. Okay, let's do the second one. Okay, not quite fully tightened. Because we may need a little bit of flexibility for the next two steps. We will tighten them fully once we've finished repositioning things. Okay. Right, as you can see, each of these has some free movement on it. Okay, now let's find our board and place it so that each of the holes on the board has one of these bolts going through. Great, we're still not ready to tighten it. First we need to put these spacers on, and this is the bit I was telling you about. As you can see, you can probably hear actually if I shut up, when I twist this you'll hear it kind of crunching on the Arduino Nano. Hear that? It does do up, but it's a little on the tight side. Alright, so you don't want to do those up fully tight just yet, because in a moment we are going to tighten from the other end. Alright, and now we take the top, cleaning off any debris, and we don't put it that way around or it won't fit. Now we want to just check that everything's going to fit, and I can see that it is. Fantastic. Now we can tighten these nuts at the bottom just by driving the screw and holding the nut still, then tighten the spacer as well, and we do that for each of the four corners. Okay, then the final step will be, then we'll put the lid on. Okay, good. Right, now we'll put the lid on. Just, if you need to, you can flex the nylon spacers very slightly if the holes don't line up absolutely perfectly, but they should. They've been laser cut after all. But the nice thing about these nylon hardware elements is that there is a bit of flexibility in them, perhaps a little more than there would be if they were made of metal. You'll notice I'm not screwing these fully in, and there's a reason for that. The reason is this. We need to use the tension on these screws to hold the sides in place. So this is the right hand side, which is the side where the USB connector is, and now we can tighten that. It's been designed so that the side is 0.5 millimeter or so wider than the length between there and there. So when tightened fully, there should be pressure on the sides which holds them in place. Okay, there. Now you don't want to over tighten it, but that seems pretty good to me. So place the sides in place. You can check with your fingers to make sure that the top and bottom alignment is good, and then you want to tighten to your satisfaction. Okay, and then check. That seems good. Now we have our RasPiO nightlight encased, and if I've done it properly, we should be able to plug in our micro USB lead. Ta-da! Look at that! Look at that! Great British engineering. Fantastic. We're done. So that's it. Your RasPiO nightlight is now assembled, encased, and ready to plug in and program. If you've never programmed an Arduino before, there's full instructions in the user guide, and I'll give a link to the user guide here. You should be able to find any information you want at rasp.io/nightlight, all one word, and there'll be links there too to the GitHub repository where you can find the example sketch. Remember, you can tweak this. You might want to tweak the values for the light sensor threshold and the brightness of the LEDs, or even the colour. It's totally up to you. One more thing, Colombo. PIO sensors need a minute of warm-up time every time when you first plug it in. Even when it's programmed, you won't get any sensible, useful readings out of it until it's been switched on for at least a minute. It's caught me out a few times when I've been cursing my software, wondering what the heck's going on. You've been warned. I really hope you have a great deal of fun and the nightlight proves useful to you. Enjoy using it, playing with it, and I can't wait to see what people do with them. This was Alex Eames for RasPi.tv. Thank you for watching.